So hello everyone, this is B.V. Raymond. Today's topic is optical fibers. What is meant by optical fibers? Optical fibers nothing but these are the thin transparent fiber of glass or plastic which is used to transmit the light in any direction or through a long distance. That is what we can call it as optical fibers. This optical fiber is made up of two things here. One is a core, that is the center of the optical fiber. This is we can take it as a core. Another one is a cladding, and along with that a protective cover. So this is a fabrication of the optical fiber. So here the optical fiber which is working on the principle of total internal reflection. The light can transmit through a long distance or any desired direction that is possible by total internal reflection process. Then, so this cladding and core, nothing but this is made up of a plastic or a glass with a different refractive index. The refractive index of a core which is much greater than refractive index of cladding, and whose thickness is like this. The core having a diameter that is 62.5 micron and cladding is 125 micron. First we should know that 1 micron are nothing but 10 to the power 6 minus 6 meters. 1 micron is nothing but 10 to the power minus 6 meters or 1 micrometer. This is what we can call it as 1 micron. Optical fiber, how it works means, when a ray of light which is entering from one end of the optical fiber, here this is an optical fiber, core, cladding, the ray of light which is entering from one end with the angle of incidence which is greater than critical angle. The ones which is incident on the surface of the core, then along with the angle of incidence is greater than critical angle. In such a condition, so this ray of light is totally reflected back to the same medium, nothing but again entering into the core. So then again this is the angle of incidence is more than critical angle, again that will reflecting back to the same medium. So this process will continues. Then the total number of total internal reflections are made here. That's why the multiple total internal reflection process happens. Then finally that ray of light that emerges from the another end with the many total internal reflections. So this is a working of the optical fiber. Optical fibers are mainly used in the communication system. In the communication system, there is an informations, like it may be information in the form of text, or it may be in the form of voice, or it may be in the form of pictures or data, like that. Those informations initially which are converted into electrical signals, the information is converted into electrical signals like this. Those electrical signals are converted as a light signals or pulse using this light converter, and that light is again entering into the optical fiber like this. So once light is entering into the optical fiber, due to multiple total internal reflection, so that will travel through a long distance. Then if the light entering into the one end, so then due to multiple total internal reflection, that will travel through a long distance and that emerges from the another end. Once the ray of light which is emerging out from the another end, so that is passes through the photodiode. So that photodiode means the diode which converts a light signal into the electrical signals, and so those light signal which are converted into electrical signal, then that electrical signals are received by the receiver. Then that electrical signal again converted into information. The information is read by the receiver. Like this communication process will continues. and in such a conditions, so this is optical fiber mainly used to passes or transmit the information from one end to another end. So this is one main use of the optical fiber. Then optical fibers which are also used in many cases, like in endoscopy, there is a study of internal organs. In such a condition, that is we can call it as endoscopy. So there is also using the optical fibers to observe or to examination the internal organs like a stomach, intestine. So then in high-tech buildings also, the optical fibers are used from the roof to other parts of the building to transmit the sunlight. Then optical fiber which is also used in to transmit the images, 3D images. So there also we are using the optical fibers. These are the some uses of the optical fibers. In dealing with the refraction spherical surface, so here the following are the sign conventions we are using, in which the first Cartesian sign conventions is all the directions are measured from the pole of the spherical surface. First one. And second one is the distance measured which is along the direction of incident light, then it is taken positive. Then the distance measured is if it is opposite to the direction of incident light, in such a condition which is taken as a negative. Say like this, if the all measurements start from the pole only, if the measurement is along this direction. So let us imagine the distance from P to C. Now the distance measuring from P to C, but the incident light direction is same like this. Now the direction of measurement and direction of incident light both are same direction, then it is taken positive. If the direction is opposite to the incident light like this, if the measurement is taken from P to somewhat X in this direction, but the incident light is in opposite direction, in such a condition the sign convention which is taken as negative sign. Next one is refraction at the single spherical surface. Here now we want to derive a relationship between object distance, image distance, it is in terms of refractive index and radius of curvature. See, xy be the spherical refracting surface which divides the two medium. One is a rarer medium of its refractive index is N1. Another one is a denser medium. This one is a denser medium. Its the refractive index is taken as a N2. Then, so here this is a pole of the refracting surface. Pole is nothing but a midpoint of the surface xy. This is taken as a pole as P, and O be the object which is present on the surface, present on the principal axis. This line is taken as a principal axis. Here C be the center of curvature, and the distance from pole, this is pole to center of curvature we can consider as a radius of curvature. PC is considered to be radius of curvature R. Now let us consider object O which is present on the principal axis, which emits the rays. One ray which is travel along the principal axis, and another ray which is passes as OA. This is, you can take it, you may take it as a A. One ray is passing along the principal axis, another ray passes as a OA, and after the incidence with an angle I, that is an angle of incidence, and this line is a normal line to the surface xy, and once the ray of light, that is OA, which is incident at point A with angle of incidence I, that is a refraction takes place, and that will travel as a AI. AI be the refracted ray, and which is these AI ray and OI ray, these are the two rays which are merges at a single point, and this is what we can take it as a I. I be the image. The distance from the pole to the object, which is considered as a object distance, u. The distance from image I to pole P, this distance is considered as image distance. Image to pole distance is considered as an image distance. Object to pole distance is considered as an object distance. Then, so let us take a triangle. Let us consider a triangle OAC. In triangle OOAP, you can consider triangle OAP. In a triangle OAP, since angle AOP is equal to alpha, then angle AIP is equal to beta, then angle ACP is equal to gamma. Then, since external angle in the triangle is equals to sum of opposite internal angles, so now we can take a triangle that is in triangle OAC. In triangle OAC, the external angle is I. See here, this is an triangle. In this triangle, I be the external angle. Since external angle is equals to sum of opposite internal angles, that is equal to alpha plus gamma. And in the triangle IAC, in triangle IAC, in this triangle again external angle is equal to gamma. External angle is equal to gamma, then gamma is equal to sum of internal angles, that is R into, that is R plus beta. Hence R is equals to therefore R is equals to gamma minus beta. So this is gamma minus, so R is equal to, if beta is moved to the LHS side, then it becomes minus beta, hence R is equal to gamma minus beta. Then from a Snell's law, we know that that is equals to N1 sin I is equal to N2 sin R. According to Snell's law, that is N1 sin I is equal to, this is that relation, N2 sin R. So for a parallax ray, small angle So if the angle is very small in such a condition, N1 actually, since sin I is nearly equal to I and sin R is nearly equal to R. Hence the equation becomes, this is equation number, this above equation becomes N1 sin I becomes I now, that's why N1 I is equal to N2 R. Then So this equation, substitute these values. So n1 keep as it is, n1 keep as it is. In place of I, we can substitute this value. See, this is the value of I. I is equal to alpha plus gamma. Instead of I, we can write alpha plus gamma is equals to n2 keep as it is. Instead of R, you can write gamma minus beta. Gamma minus beta. Then we know the value of alpha, beta and gamma. The alpha is equal to, in the triangle, see here, this is an alpha, tan alpha is equal to opposite divided by adjacent. So opposite is equal to now AP or PA, that is equal to PA divided by PO. Comma beta is equals to, see here, this is a beta. So in the triangle AIP, beta is equal to tan beta nothing but opposite divided by adjacent. Opposite is here PA divided by PI. And so next one is gamma. Gamma value is, see here, so in the triangle ACP, that alpha is equal to PA by PC. PA divided by PC. Hence, substitute these values in the equation number 1. Substitute these values in above equation. Hence, the above equation 1 becomes so that is n1, alpha value is PA divided by PO plus gamma value is PA divided by PC. Equals to n2 into gamma nothing but PA divided by PC minus beta nothing but PA divided by PI. So now, so PA here, keep it outside, and PA here, keep it outside. LHS PA and RHS PA get cancelled. Remaining, so now n1 is substitute, multiply here in the given both sides of the equations here. n1, that is, it becomes n1 into 1 divided by PO, that becomes n1 divided by PO, plus again n1 is multiplied here, hence it becomes n1 divided by PC, that is equal to, again n2 multiplied here, it becomes n2 divided by PC minus n2 divided by PI. So now, so both PC equation, that is n1 divided by PC, send it to the RHS side, and n2 divided by PI, send it to the LHS side. So by exchange, it becomes n1 by PO minus n2 by n1 becomes plus n2 divided by PI is equal to, here already n2 by PC keep as it is, then this n1 send it to the LHS side, it becomes RHS side, it becomes n1 divided by PC. Now, so this equation becomes, now these values of PO, PI, PC, PC, these are the values which can, like, you can write like this, it becomes PC is common here, hence you can take it as a n2 minus n1 divided by PC. n2 minus n1 divided by PC, write like this, and along with that, so apply the sign conventions. By sign conventions, by sign conventions, the above equations becomes C. PO nothing but the distance from pole to object, which is object distance. Here object distance is measured from the pole, that is opposite to the incident light, hence it is taken negative. So this value becomes negative according to sign convention. And PI is nothing but it is a distance from pole to image. The distance measuring is along with the direction of incident light, hence it is taken positive, keep as it is. And PC nothing but distance from pole to center of curvature, and the direction of the measurement and direction of the incident light both are in the same direction, hence it is also positive. Then by simple adjustment you can write that is N2, this minus term is later you can write, that is N2 divided by Pi minus N1 divided by PO is equal to N2 minus N1 divided by PC. These values can written as, so this can be written as N2 as it is N2 as it is. Pi is nothing but object distance, sorry, image distance, pole to image. Pole to image is the image distance which is taken as a V divided by V minus N1 keep as it is divided by PO. PO nothing but distance from pole to object is object distance which is taken as a U. This is U is equals to N2 minus N1 divided by PC. PC nothing but distance from pole to center of curvature, it is taken as radius of curvature R. So this is the relationship between object distance U, image distance V in terms of refractive index and radius of curvature. This is the relation. Thank you.